because I did my undergrad back in India. This was in 1996. I graduated, and since then I've been kind of moving. I've been working in Singapore, and then I settled in the US for the last 20 years. It's an opportunity for me to share some of the research what I've been doing, right? So hopefully, this could have been a live presentation, but maybe in the future we could actually do something similar. Already. So my topic today is actually micro and macro scale modeling, simulation, visualization of buildings and cities. And if you go back and look at my background, I think that was one of the interesting things which I was listening when Dr. Shanmugapriya was talking about in terms of research and so on and so forth. I think most of you guys are interested in doing research, and this is amazing because you don't want to necessarily be a simple practitioner, an architect or landscape architect, but rather you really wanted to do some research. You wanted to make some changes to the way how things are, right? So that's amazing. Again, all of my roots are back in India, and the professors there were amazing, including Dr. Subbian. We have another professor, Dr. Ram Prasad. We do have Dr. Thirumar and so on and so forth. I mean, these were some of the faculty, who kind of pushed all of us in terms of, is that all you can do? That's a question which we need to keep asking, right? And that's exactly what they asked us. And there you go. Some of us are doing very good research. Okay, so I just want to kind of expand and talk about what are those major things, those three major domains which Dr. Murugesan was talking about. And I'm still trying to figure out, just give me a minute. Okay, there you go. Okay. So these are the three major domains which I work on, right? So modeling and simulation, simulation visualization, and then within visualization, we have the virtual reality, we have the augmented reality. If you look at the modeling and simulation, my focus is more towards building energy. Again, if you go back and look at my 1996 thesis from R.S. Trichy, it was about design recommendations of energy efficiency buildings in 3 climatic zones in India, right? So I've kind of very much involved myself into building energy, and then kind of now what I do is I kind of focus more towards modeling and simulation, not just in single buildings, but also looking at buildings at an urban level, right? So a very good example is, can we model all of the buildings in Chennai, right? And if that is the case, how do we do this? There are two different ways to do this. One is you could do a data-driven approach, basically using neural networks, machine learning algorithms, and then run all of these things. The other thing is you could actually do physics-based models. I'll talk about some of these things in my presentation. So the question here is, what are these two different things, and which one is easy, which one is tough? Is there any way that we could actually kind of combine some kind of a system where you would be able to kind of run all of these two different models? If you look at data-driven approach, it's called a black box approach. Physics-based model is called white box approach. So what we're looking is in terms of gray box, modeling approaches and so on and so forth. So that is one set of things. And as I kind of expanded my research, I also entered into urban air quality and impacts, and that's exactly what you see here. The last several years, we started to use drones. I think drone is kind of ubiquitous. It's almost like having a PC in your home, right? Pretty much everybody has a drone. We just fly. The question is, what do we want to use it for? How do we kind of obtain data and improve our models? So those are some of the things which we work as well. If you look at the second domain, which is simulation visualization, this is kind of a very important domain. The reason is, we could actually do lots and lots of simulation. The larger question here is, how to visualize the data, right? I mean, you could actually put data in terms of numbers on the paper, but nobody can even understand that. But how do we kind of, prepare this data and then kind of upload it into a system such a way that's easy for people to kind of visualize? Again, we should also allow people to kind of make some changes. For example, let's say running some statistical analysis. I mean, how do we kind of, allow them to make those changes? So we developed a DSIM software. DSIM is Dynamic System Information Modeling software. It runs on R programming. So basically the interface, what you see at the bottom here is actually the University of Pennsylvania campus, right? So that's exactly where I studied. So basically you could actually remove some, run some analysis, quick analysis from the data. And the last domain, what you see here is kind of expanding the visualization. It's not a visualization which we wanted to have this on a 2-dimensional platform, but we wanted to kind of expand this and look in terms of 3-dimensional platform, right? I mean, the question is, can we walk into a building virtually? Can I interface with building data, right? And that's kind of using augmented reality, right? again, I'll talk about some of these things. And one thing which I want you to let you know is if you are an able researcher, you wanted to understand more about some of these things, just visit my website. You can just Google my name, UF, you'll be able to see it. I also noticed that Dr. SHANKAR was talking about issues in terms of accessing journals. Do not, feel shy. Send me an email if you want certain journals. I'd be more than happy to kind of send it your way. That's a little secret anyways. Okay, so I'll talk about some of these things. And currently we have close to $1.25 million, which is close to 8.5 crores or something in Indian rupees. These are the projects that's actually ongoing in my lab. I'm the PA of almost all the projects except the last one you see here, which is a million cool roofs in Indonesia. That's actually happening as we speak. Several projects have been completed. And then in terms of equipment, this is kind of very important, right? I mean, if you want to conduct research, you need to have the right equipment. Okay, this is something which I really realized, the beginning stages of my, when I joined as a faculty at the University of Florida almost 11 years ago. So I kind of started to spend quite a bit of money on equipment. Whenever we submit projects and proposals, we kind of assign certain amount specifically for equipment, right? Some of the equipment expensive, as you can see here, the one in the middle is kind of, it's called UHU sensors. The one on the right side, those are actually the air quality X sensors, and each of the sensors costs close to $1,000. But it's too expensive, right? I mean, if you want to kind of introduce some of the sensors in the neighborhood, it's kind of like really expensive. So what we do is we went back to the fundamentals. So now what we do in my lab is we put together sensors, we purchase individual sensor components, we kind of assemble all of the sensors, and then we kind of calibrate them based on UHU and the air quality. These are approved by the US EPA, and then we kind of use those systems, right? And we do have 2 drones. The drone, what you see here is kind of the one which we purchased 4 years ago. The idea of drone technology is, again, certain times, it's very difficult for us to kind of access information or obtain information. So what we do is we attach sensors. In this case, what you see here is a wind anemometer. I'll again talk about this a little bit. And then, in addition to those equipment, what we have is we have lots and lots of other equipment in terms of virtual reality. We have several virtual reality goggles, sensors. There is a mat you can see at the bottom, right? So basically, you walk into the mat, you pretty much understand all of the different the postures. So as you kind of walk, you'll be able to see the pressure points and everything. So each of those sensors, each of those mats have close to 15 to 16,000 sensors. Pretty much we can get this information. All right, so I want to recognize all of my students. Once upon a time, we were all students, myself, Dr. Lakshmi Tilagam and so on and so forth, right? So without students, very difficult to kind of run multiple different researchers at the same time. I'm very fortunate to have very good students. Currently we have 5 students who are working with me on the chair of their PhD. Everybody is funded through projects. Most of them are funded through projects. And then if you look at the past, we have 5 students who have graduated. Only one has gone to the academia, which is kind of very interesting. Everybody has gone to the industry. They're working either in San Francisco, California, or so on and so forth. The reason is the industry needs people who can run all of these data or develop some of these technologies. Okay, so I'm trying to kind of motivate some of my students to go to the academia, but let's see what happens. 2 of those students are going to graduate. The first 2 listed in my current column. Hye-Kyung, she's from South Korea, and Hee-Zhang is from China, right? So 2 of them are going to graduate. And I have 2 incoming PhD students who are fully funded starting this August. One is from India, one is from Nigeria. So I'm also the interim director for the graduate programs and research. So we go through all of the applications. I'm in charge of kind of, admitting students, both master's degree and PhD degree in my department. So we work on all of these things. We get the top tier students who applied, who wanted to work in some of the related fields, and then we get them here. All right. So let's go to the actual research work. And before that, I just want to give you some achievements and capabilities of our lab. Our lab is situated in a building, which is the Solar Decathlon House. Some of you may know that the US Department of Energy kind of conducts this kind of competition where they would say that they would actually define the size of the home. They would also define how much money you can spend. and students and the faculty would kind of work together and then identify and develop, construct the solar decathlon house. So this house secured several awards, and right now that is my lab. So the lab is a net positive energy building. I think some of you or most of you may know what it is. So what you see here is kind of a collection of different, some other examples of different researches, what we have done. You could see the virtual reality goggle. The person is also wearing a cyber glove. I'll talk about this again in 20, 30 minutes. And then we also complete a lot of research. And some of you may know Natural Science Foundation. It's kind of very prestigious in the US. I've been the PI for a couple of Natural Science Foundation projects, awards, and so on and so forth. Okay, so what is today's talk about, right? And as you have seen, my interest is more towards modeling and simulation, also visualization, right? And when we look at modeling and simulation, we have to look at them in two different scales. One is in terms of micro scale modeling, another one is macro scale modeling, okay? There are always problems, right? I mean, that's one of the reasons why we researchers enjoy, because without problems, we can't develop solutions, right? So some of the problems, let's talk about the micro scale modeling and simulation problem, right? On the left side, what you see here is actually an infrared thermal image of a roof. This is a roof that the image was taken in the north, I think it was in the Northeast. You know, Northeast is very cold, and the winter, it snows a lot. Okay, and this is the roof, what you see here, right? I mean, you could see the roof, it's kind of interesting. You see little yellow spots on the roof, okay? And then to the right side, you also see the way how the snow has melted, right? So snow has melted wherever there is a thermal bridging effect. I think some of you may know this, thermal bridging effect, because the buildings are conditioned. And in that particular climate zone where it's very cold, it's snowing, we always use a metal fastener. A metal fastener is kind of a metal bolt to fasten the insulation on top of the roof. So when there is conditioned space, basically in winter it is heated, the heat actually escapes through the metal fastener, and then it escapes to the exterior. And that's one of the reasons why you see this little yellow spots, right? So that's a major problem. And if you look at the state of Florida, we do have hurricanes. Some of you may know lots and lots of issues of hurricane. So we have to, according to law, we have to introduce more metal fasteners. So think about this. You have insulation to prevent heat exchange of flow, right? And then you also have these metal fasteners which kind of conduct heat. That's kind of, you know, ridiculous, right? But that's exactly what is actually happening, right? And my friend, who was my classmate, some of you know, Rupesh Gulati, he used to work for Disney at the time. And he called me, he said, "Hey, Ravi, I have this problem. Can you work with me and we can figure out something about this?" And then, we started to work on some interesting concepts. I'll talk about this in a minute. So that is a problem, right? So that is a micro scale problem because we wanted to focus on a section of roof with metal fasteners. We want to understand more and more about that small area in a very simple manner, right? We could also use complicated simulations, but we still wanted to kind of develop some policies that would kind of, impact not this particular building, but in general, mostly the North America, which is the US and Canada. So that's a micro scale problem. The macro scale problem on the right side is cities, right? I mean, cities, what you see on the right side, there's a map of Gainesville, Florida. That's exactly where the UF is situated. Gainesville, Florida has a lot of residences, right? I mean, we have buildings being built in the 1950s, 60s, and so on and so forth. The larger question here is, what policy decisions we have to take in order for these buildings to be still consume less energy over a longer period of time? Again, when we talk about longer period of time, I'm not talking about 2022 or 23. I'm looking at 2040, 50, and 60s. Okay, the reason is buildings don't change, they don't demolish. But then if the city is able to come up with some new policies where we'd be able to kind of implement some of those changes, for example, increasing insulation or changing to a certain window type, which has a different specifications, right? Then these buildings can still be there for the next 50 or 100 years, but still not consume too much of energy. So that's a macro scale problem. Macro scale problems have to be solved slightly differently in the sense because it's not for one building. You have to kind of generalize some of those assumptions and bring about a solution, right? So those are the different things. And then, as I told you, there are solutions for this. On the left side, you have a micro scale modeling and simulation problem. You have a solution. Basically, we take a a section of a roof. We understand this in detail. We model that in certain specific software. And on the right side, we have a macro scale problem. There are two different ways of solving this. One is going through the route of black box modeling, which is kind of, using all the existing data, running all the, simulations, understanding the, all the errors and whatnot. On the other side, you have the white box modeling, which is like physics-based modeling from ground up. Okay, so these are two different things. And as I told you, I'm a licensed architect. I believe my architecture license is still valid in India. I think it ends in 2020 or 2021. So which means I love visualization. This is something which I really love it. As I told you earlier, visualization could be in a simple 2D information platform, such as a website, as you can see here, or it could also go extend into virtual reality or augmented reality. I'll talk about some of the examples what we've done earlier, okay? So again, in terms of all the data, what we obtain from micro scale, macro scale, we have to visualize, and that's exactly where we're going from here, okay? So again, this is the example I was talking about earlier. As you see here, you see a metal fastener. And these are the fasteners that go through the roof. And again, this is a thermal imaging and so on and so forth. So that's a good problem to be resolved. And we used a certain software to kind of understand there are two-dimensional heat transfer software. There are also three-dimensional heat transfer software. Fortunately, you can't do research if you don't have money, right? And fortunately, this is one other important thing about researchers. We should be able to write good proposals in order for us to get money from these funding agencies so that we can hire students. We can also kind of, help them learn and they become researchers as well, right? If you are planning to do only one research, which is also good, you could actually spend your time and then kind of work on these things. But if you plan to do multiple research in the same area, then I think you need to have students to kind of work. So in the US, we have 8 climate zones. So you can see where Gainesville, Florida is located. Again, the climate zones are based on both temperature and humidity, right? And this is a climate zone map, what you see here. The reason I'm showing you this is because, in India, we have ISHRE. ISHRE is I think it's the Indian Society of Heating, Refrigerating, Air Conditioning Engineers. They do have climatic zones and so on and so forth. That's kind of a very relevant, very direct, I wouldn't say copy, similar information in the US, which is called ASHRE. Okay, and ASHRE has specific requirements for, the insulation, right, for the roofs. You can see here, I've kind of, redlined some of those information. If you're looking at a metal building, as in the case of the Disney, most of the commercial buildings are metal building in the US. Your non-residential, insulation would be R19, which is resistance, right? Again, these are all in IP units. You have to convert this to SI units, which is used typically in India, okay? But there's one important thing which I want to tell you. These numbers, what you see here, let's say look at this number R19, which is for metal building, insulation minimum R value. This number or this recommendation does not include the metal fasteners, okay? On the left side, what you can see is a section of the roof where we can see a metal fastener, that thin line that goes across the insulation. So you can see the multiple different layers. We have a metal deck. Okay, these are commercial buildings mostly. And you have an insulation, you have a covered board, and then you have the EPDM, right? And then what you do is you actually have a metal fastener. And that metal fastener conducts all of the heat, okay? So basically what we're trying to say is even if you kind of comply with the code that is required in the US, it doesn't mean that that's the most efficient because metal fasteners conduct heat. It's called thermal switching effects. So we conducted lots and lots of research. We wanted to kind of identify the different typical types of metal, the roofs that's being used in the US. We identified 8 different types, and then we ran simulations for those 8 different types. So we looked at the leakage in terms of how much of energy is being wasted, and all of those information. And then we also kind of conducted, sometimes it's very difficult to talk about total heat. In this case, you can see this on the left side in terms of BTU per H. But if you convert that into a number, which is a dollar sign, right, or a rupees, right, people can easily understand because they know that they're going to waste money and they'll be very much ready to kind of do something different. So funny enough, as we are working on this, I got a call from the National Research Center from Canada. They said that they're also working on similar things because they found that metal fasteners are also a big problem there, and they were kind of using something similar to the US, right? So the NRC Canada were using experimental setup. It's called a hot box system. So you would actually have an actual roof with all the metals, insulation, everything. And in addition to that, you will also introduce lots of sensors. And they said, why don't you do the empirical calculation? So we did the empirical calculations, they did the actual hot box, and we were comparing the results. So fast forward, Canada may also update their energy codes with all the requirements, which would include metal fasteners. I don't know when it's going to happen in the US, but it's going to happen very soon. But if it happens, the research actually started in our lab 4 years ago. Okay, so it's going to happen. All right. The next interesting thing is all about creativity. This is something which I really love about it. For example, if you walk into a air handling unit room, you can hear lots and lots of noise and sound, right? So what you could do is, the question is, how do we know that which system is failing? Okay, one way to think about this is like going to the doctor, right? You go to the doctor, no matter what, they're going to check, hear, listen to you, okay, and understand, okay, how you are doing, right? So I kind of used the same kind of concept for these buildings. So what we did was we used acoustical systems. In this case, we identified specific cell phones that had a very high fidelity microphones. We literally purchased this on eBay, and people they kind of charged more money because they knew that we're looking for these cell phones. So we bought 10 of those things, and then we would kind of listen to the noise. We place the cell phones inside the AHU room. And then the first thing we do is we remove the human voice, because that's kind of intrusive. There's a lot of privacy issues in the US. And then we send the raw data to the server, and then we process the data. So what do we process, right? So if you look at the different types of faults that occur in a typical HVAC system, these are mechanical systems. So basically, whenever there's going to be a fault, there's going to be a small change in the audio signature, right? So we are trying to kind of capture those audio signatures, right? So basically, the sensors were located in the Hahn Museum. It's one of the buildings within the UF campus. And then we kind of, as I told you, right, we sense, we do some basic localized analytics, and then we remove everything for privacy. We send to the cloud, and then we kind of run out of these things. So this is how the sound looks like. So basically, for the human ears, it looks like it's noisy, but for the computer, we can actually kind of program such a way that they could split all the noise into specific equipment type, as you can see here, right? Fan makes a specific sound. The important thing is, if they can listen long enough, we know when the systems are going to fail. Remember, I told you it's mechanical systems. They fail, they're going to change, they're going to be an issue in terms of their audio signatures. So basically, you listen long enough, you'll be able to do this. So the bigger idea here is we wanted to kind of develop systems. For example, let's say a washing machine, right? We are looking at some of these things as well. So for each of the washing machine, it has a specific signature. So basically, once we learn all of this information, we will upload this as an app. You just place your cell phone on top of the washing machine, leave it for maybe 30, 40 minutes, and then the app should tell you when your system is going to fail. So basically, you start saving some money so that you can put in a new washing machine. Okay, so this is a NSF project. I was a PI, and we still have a lot of publications out of this particular project. At some point, we're still kind of trying to see whether we can actually collaborate with any other company so that we can actually, get this happen. Okay, most of you may know the impact of cool paints. Cool paints doesn't need to be in white color. So basically, it's a paint with some reflective coating. So basically, you would kind of reflect the sun's heat, right? So this is again a major issue. This was a project in 2016 where I traveled to South Africa several times. And this was kind of supported by the US Department of Energy. And I'll give you a context of what it is. This is some kind of similar situation that is happening in India also. So when Nelson Mandela came out of the prison, he said that he wanted to provide housing for people, mostly the low-income housing. He said they cannot live on the streets. So pretty much houses were built, as you can see here. These are called RDP homes. RDP homes are simple home, like you see in the diagram below. It has a living room, it has a kitchen, it has a bedroom, and it has a storeroom, nothing more, nothing less. Okay, very simple. It's like 400 square feet or even less than that. The problem with this is, since it was a government mandated program, it was kind of installed in several places all around South Africa. There were very small changes that were made depending on climate. Remember, we talk about climate changes, right? You go from Chennai to any place in Kerala, or you actually go to or any place, significant change in climate, right? Same thing actually happens in South Africa. So what we did was 2016, we said, hey, you know what, let's kind of work on some of these things, try to see if we can develop some, provide some help. We just did. We didn't have any. We didn't request any money at that point in time. We just did, and then subsequently, the U.S. Department of Energy also found that we were working on some of these things, and then within a year or so, we were working with the South African government. Okay, so if you look at South Africa, there were codes very similar to the codes what we have in India. It's called South African National Standards for Building Consumption, Energy Consumption, right? And they have two specific codes. They also follow ISO codes as well. Okay, on the right side, there is a table. If you look at the way how they define the efficiency for these buildings are very straightforward. They have a certain type of occupancy. They have a description of building. And then all they're saying is, if you're in this particular climatic zone, you cannot exceed this maximum energy consumption, which is kilowatt hour per meter square, very similar to the energy use intensity, okay? And the problem is, all of those numbers are very high numbers, okay? But what we need to do is we need to bring that down, right? It's very difficult to kind of make changes at a national level. So one of the simple change which we did was we said, why don't we focus on the various building types, right? So we identified several building types, 10 different building types. We also identified 7 climatic zones. So the time when we were working, we knew that South Africa was also changing their climate zone map. Instead of 6, they were going for 7. So we had access to that new climatic zones. We identified specific representative cities because we cannot model for every city in the climate zones. And we work very closely with those guys, right? And the idea here is very straightforward. We run a baseline model, and then we will develop energy efficiency measures. And these measures are going to be cost effective because it's very difficult for anybody to kind of spend a lot of money. And then once you have those measures, then we will develop the different potential impacts and so on and so forth. Okay. So on the left side, you can see here, these were the 10 different building types which were identified in South Africa. 2 are residential, 8 are non-residential buildings. And we also wanted to give some relation to the existing classification, right, in the code. And we also see the area. And these are the 7 different climatic zones. In South Africa, it's not 6, as I told you, they're still working on the 7, kind of reorganizing the climatic zones. I also discussed about the importance of identifying the energy efficiency measures, something very important, especially for developing countries. You don't want to throw in something that's going to be very expensive, cost prohibitive, right? It has to be affordable. 2 things. One is people should be able to afford, as well as the city governments, so they can come up with some new policies. So these are simple efficiency measures. You have roof reflectance to walls or roof. Basically, you could actually paint. There are specific paint that's available. You just paint, and then it kind of reflects heat, okay? And then we also want to introduce the insulation, okay? If you go from ACM 1 to ACM 6, basically you go down, basically we're increasing the cost. So if you wanted to stay anywhere at the top. So this project was there for 2 years. There were 2 to 3 different times when I went to South Africa. As I go there, I also kind of conduct energy modeling classes. I work very close with the University of Pretoria. We have agreement with them. So, I kind of sit in their PhD committees and so on and so forth. So the end goal, as I told you, is about policy. It's not about, convincing a couple of people. We wanted to develop policy that would affect the entire nation. So based on that, we wrote the final code language. This is the code language you would be able to see in the next version of South African National Standards. Okay. On the left side, you could see the code language for roofs, because it's very difficult to convince them for the walls and so on and so forth. So we maintain for roofs. And then we also had code languages for Windows. Okay, Windows are very tricky. I think most of you may know this because we want to have good daylighting in, which is visible transmittance, as you see here. But we also want to prevent heat coming inside, especially if you are in a climate zone, right? Which is very hard. And you also have something called U factor because Windows do conduct heat. Okay, so these are the three major thermophysical properties of window. And in the US, all of the windows are certified by the National Fenestration Rating Council, which is called NFRC. You go and purchase a window from any place, it comes with a little label that's called NFRC label, because NFRC develops standards, codes, and whatnot specific to the windows. And I'm the secretary of the board of the NFRC there. So, we spent quite a bit of time. So this is the code language. Okay, fast forward, last year, the Million Cool Roofs Challenge came about, with close to $1 billion in funding. And, subsequently, I was working with, University of Indonesia, University of Pendidikan in Bandung, Indonesia. Okay, and then I collaborated with the Indonesian team, and then we won 100, although it says 100, it's actually $125,000. So basically, we moved from not just theoretical design, what we developed for South Africa, but we actually went and started implementing this. So the team comprises of Beta. She's a professor at the University of Pendidikan in Bandung. We have another person from California. And I wasn't able to go to that particular event because that was the time when they had an agreement with the city. The city was ready to kind of implement the school roof systems all across, but I was actually in the poster, if you can see there on the right side. Okay, so what was happening? So this actually started before the COVID-19 pandemic. So they completed close to 15,000 square meters of roof paints. These are the different types of homes. Again, it is not just painting because this is also research. So wherever they would paint, they would also kind of monitor all of this information in terms of, everything to do with temperatures and so on and so forth. Okay. All right. So we did also monitor indoor air pollution. We also monitored schools. We are still working on the results. So what happens actually? So now we are going to a next interesting thing, which is I think I told you this earlier, right? The drone. Because if you have an existing building, we do not know every material degrades for a period of time. The question is windows, right? Windows degrade again. Every time you have to replace the window, let's say 20, 30 years. But the question is, how do we convince the owners, right? So one way is when the windows are non-operable, how do we go and determine the U factors? So the way how we did was we are still working on the system. This is under provisional patent also, okay? So basically what we would do is we would use a drone. We would attach the anemometer. We go close to the window. We capture the information. And then we also send infrared thermal imaging so that we capture the information, surface temperature, and then we would do the reverse calculation to determine the U. Okay. So this is one thing which we did. The good thing about drone, as I told you, is if you can see some of the windows are non-operable. So this is the Rinker. So we did that. Again, the time is 6:40. The time is, I think it's 40 minutes since my lecture started. So I'm going to make it quick. This is something, an interesting thing. I mean, occupant behavior is it's a huge topic. Okay, and this is actually one of my PhD students' dissertation. We worked for more than 5 years on this particular topic. Okay, when I was a PhD student at Penn, I really wanted to work on the topic. I didn't have time. So, when I moved as a faculty, I thought I should work on this topic. So think about this. Whenever, you have buildings, buildings that are operated by humans or occupants, right? So if you look at the way how the energy simulation is conducted, they focus more on the number of occupants, not specifically in terms of occupancy, the behavior, right? And occupant behavior is huge because, it kind of make or break a building in terms of energy efficiency. So there are three objectives for this particular research. We have objective one. Basically what we did is we developed something called an agent-based modeling. So we represented the occupants in the building as agents, and agents behave. The agents have similar behavioral function to the humans. For example, in this particular case, he modeled me there is an agent called Ravi, and then he represented Ravi to represent few faculty in the building. Okay, and agents have perceptual types: thermal, vision, air quality. They have behavioral definition in terms of whether they want to open the door, open the window, open the blinds, close. They also have certain goals, standards, and preferences. Okay, so that's the occupant behavior model. The second one is very important because we can't just develop a model. We need to do validation, right? So we kind of acquire data on site using sensors. And the third one is how do we bring all of these things together to understand the effect of occupant behavior. Okay, I'm going to skip most of these because we have close to 10 publications, including 3 to 4 journals. I think I want you to kind of go and refer. There is one significant change in this particular model, right? Look at this. Whenever there is an input of the objects, there is also always a perception. And then if it had been a typical rule-based system, it goes to 1, it goes to 2, and then it straight away goes to an output. Because the rule tells you, hey, you know what? If it's thermally uncomfortable, do this. So it goes to 6. But in the case of this particular agent-based model, what we do is we look at the goals and systems. So basically from 1 perception system, it goes to understand the personal properties and also looks at the value systems. And then based on the highest utility, it goes to 6. Okay. Again, the details are in the paper. Again, as part of the validation process, we did kind of put together sensors and so on and so forth. Again, there are certain surveys which we have to kind of use as well because we don't have sensors for everything. 2 things. One is it's impossible because we need to have unlimited amount of money, which is not possible, right? So we kind of use some survey techniques, and then we kind of develop these evaluation metrics. In this case, we use 4 different types of metrics: true positive, false positive, true negative, false negative. Again, the details are in the paper. And we used building controls virtual test bed from the Lawrence Berkeley National Lab. So basically what it happens is, if you look on the right side, Energy Plus is the engine we use. So whenever Energy Plus runs for that particular minute, it would look at the information that is being, those inputs. It outputs environmental conditions in terms of indoor environmental condition. And then we use that to the agent. So depending on that condition, the agent would behave, right? And then it's kind of, it goes back and forth. These are some of the information. Again, I'm going to skip this, but I want you to kind of, if you're interested, let me know. And there's so much of literature out there. Okay, these are some of the literature, what you can see here. All right, so whatever we saw until now, it's all specific to one building's looking at understanding. Right now, we go to the macro, the bigger problem. Remember earlier I was talking about looking at how this climate change would actually impact buildings. Okay, for the city of Gainesville in Florida, we know that 3 years are very critical for us: 2041, 2057, and 2063. The reason is because they identified that one of those is going to be the coldest and one of those is going to be the hottest climate. Okay, when I say the coldest climate, doesn't mean that it's going to be colder than what we have right now, but it's going to be comparatively, relatively, it will be cold. Okay, so as I told you earlier, so there are 2 ways to do this. One is black box, another one is white box, and the combination of these 2 is actually called the gray box. So we are getting to the gray box. One PhD student finished his PhD in 2019. He worked on this black box, and then my current students are also finishing up. She's going to finish up using the city of Gainesville data, and she's going to continue on that. I focus more on the black box. I'm sorry, white box. I'm going to give an example of the white box modeling, what you see here. This is again based on our research, right? And this is what I was talking about. In the future, there is going to be significant change in climate. The larger question is, what is that, right? Okay, so here, what we do is we gather data. Again, the most important thing when we want to do research, especially at a large urban level, is to kind of automate a lot of these processes, right? And most of us are good in computers, right? So we should be able to do this. So we use Python for this. So we would gather all of the data, the parcel data. Once you get the parcel data, we get the building footprint, and then we would kind of gather that information, and then we could easily, automatically create a model. And then we also, these are some of the specific, functions which we created. And then using that information, what we do is then we go and look at the Florida code. Remember, whenever the building was built, there's a specific building code they have to comply with. So which means we know exactly what they would do. Most of the time, the owners comply with the basic code. They don't like to go further, right? We don't know what they kind of implemented, but most of the time, kind of, very straightforward. So we use this kind of a table to understand what properties they have kind of used in terms of the building, the materials, and so on and so forth. We use this information, and then we ran this in supercomputers quickly because we have close to 50,000 buildings in the city of Gainesville, just residential buildings. And as I told you, once we have this information, we calibrate the models because we want to understand, we want to make sure that they're not way off, especially when we introduce the new weather files for the years 2041, 57, and 2063. And this is the result, right? Whatever you see in blue is the current energy consumption in terms of different energy consumers, cooling, interior lighting, exterior lighting, interior equipment, and so on and so forth. And whatever you see in gray color is the hottest that's going to happen in 2057. Look at the cooling alone, because this is Gainesville, Florida, right? Cooling is almost double. The larger question here is, does a city have the necessary support so that they can actually increase the generation facilities, right? And the electricity generation facility. That's a larger question, right? Again, these are just existing buildings. What about new buildings? Even if you look at new buildings, the code, what we have right now is based on the past 10, 15 years worth of weather data, not for the future. So that's going to be significant change that has to happen. Okay, so now we are again looking at climate change of building energy use at a much larger scale. This is one of the recent projects which I've been working on. This is from the National Science Foundation, again using drones. What we do is we have actually 2 drones. This particular drone has an infrared thermal camera. So we use this, we fly. This is the lab. What you see is my lab here. Okay, and then we do 2 things. One is not only kind of look at the envelope energy leakages because of, I think we discussed about this earlier in terms of all of the insulation properties and so on and so forth, but we also go one step further. We also want to understand the lowest floor elevation. If you look at Florida and most of the coastal areas in the US, we have flooding. Flooding is huge. The question is, can we determine the lowest floor elevation so that we can come up with some policies to help people, right, or the cities? So 2 months ago, I think it was 2 months ago, we went to the city. We got permission from the local government, and then we ran these drone flights. We identified few cities, and then we went there. It's kind of a different experience, to go to the cities and then to work with those, people there, right? So again, this is a very simple example. We had people coming out and asking us. I mean, why we want to run drones is because, one thing is we get good data because we could actually capture that information, not just the regular camera, but also infrared thermography. And in addition to that, we also kind of, automate the process. The idea here is to do capacity building, which means in the next few years, we would work with the city governments and they could do all of these things. We don't need to necessarily do this. And, as I told you, lowest floor elevation, this is the one which I was talking about. Once we capture that image, our code will run. It will determine the height of the elevation from the floor. And then we would also use AI techniques to kind of, also update some of those existing information. So this is exactly where we are going. So we worked on 2 different counties. And then right now we have submitted a proposal for $1.5 million. Hopefully we'll get that money. Okay. So that's one other thing. As I told you, visualization. This is something which I love it. I'm going to go fast here. Again, there are a lot of publications which you can see. This is the one I was talking about earlier, right? It's interactive web-based visualization of city data. Okay, this is the University of Pennsylvania campus. So you could actually, this uses the RStudio. So basically you could go back, it's a statistical analysis tool. We have multiple different tools we use for actual research. The one on the left side is a very simple tool. It's a virtual reality goggles with a simple interface to interact with some of the information. On the right side, what you see here is called the Cyber Glove. Cyber Glove is a very simple glove. It costs close to like $20,000, right? So basically, once you're inside the environment, you could actually hold, any object you want. You could actually feel a little bit because the tip of this particular glove has simple vibro-tactile feedback sensors that will give you the feel of what it is, but you can't physically hold them. It doesn't have the weight, but it can actually feel when it touches. So that is exactly how it is. Again, there was one work which I did in 2005 when I was a PhD student, and then later on I used that information, and I was able to get some good funding in order for me to purchase all of the equipment. Okay, we have quite a bit of work done in this area. One is Parkinson's disease. We have lots of some of people who suffer Parkinson's disease. The question is, can we improve the quality of life for these persons, right? So this is one of the work we have done. Again, we don't have a lot of published data here, but I can actually refer you to one of the things which is available. I'll talk about this in a minute. This is actually the mat I was talking about. As you walk into the mat, you'll be able to see the information, right? So I think there is a link to the YouTube, I believe. Okay. Okay, I'm going to skip this. It's going to take quite a bit of time. Okay, let's keep moving on. Okay. There is a virtual reality demo. I'll give you the website so you can actually, take a look. One of the other things which we do here is we also look at the housing and urban developments, different homes. So these are homes designed for people. And then the question is, as people get older, a lot of things actually happen to the physical body. So the question is, can we kind of make small modifications and then kind of, allow them to use the same home instead of moving out of the home? A very good example is, as we get older, we won't be able to use the shelves that are on the higher level, right? So how do we modify these homes? So there's quite a bit of work that was done. Again, this is a very simple example of some of the hardware, what we use here, right? So I'm going to see. Okay, I don't see it here. Okay. So this is the HTC Vive. That's the cyber I was talking about. In addition to that, what we do is we also attach sensors to the different parts of the human body so that we can also monitor the movement and so on and so forth. This is less than a minute video. I think let's quickly watch this. I see there are a couple of chat comments. Okay. Okay. All right, anyway, so I'm going to skip these. Let's, this particular video, I'll post the link to the video, let's say. By the way, they're all PhD students. Okay, so we collaborate with the College of Engineering. We have professors from there as well. Again, this is much more than architecture, right? So we need to kind of work with them as well. Okay, let's skip. Okay, all right. So moving forward, there is going to be a very interesting event. My lab, we have an international workshop. This was a workshop that was conducted at Columbia University 2 years ago. We tried to bring in the US national labs as part of the workshop. Again, this is called the UrbSys workshop. UrbSys lab is my lab name. So we conduct this as an UrbSys workshop. The next workshop is going to be conducted in November. It's going to be in Portugal. So I will send this information to Dr. Lakshmi Tilakam. So feel free to communicate with her so that you should be able to participate and join. We welcome papers. It's kind of difficult to publish, but send me the papers. I'll be more than happy to kind of help you guys refine the papers so that it can be published in our workshop. So you can come and present, okay? Again, if you have any questions, send me an email. You have that email address here. And that's my personal website. It's called Build Ecologist. And that's about it. So it's almost an hour. So back to you, Lakshmi.
Thank you, Ravi. That was it was very exciting to see the kind of real life problems and situations that you take and convert them into challenging, research projects. Amazing. I was very interested in the last project that we're talking on, improving the quality of life of Parkinson patients. Can you just very briefly tell me something like, is there something innovative that you're trying to come up with? What is it, your idea or something, the core idea or something?
Absolutely, yeah. So you can see my screen here, right? So the only problem here is if I'm able to present this, you won't be able to hear. My suggestion is this is a 5-minute video. Can I share this in the chat? And Lakshmi, do you want to run this video? Because you're the host, it's easy. I'm going to stop sharing my screen. Because this particular video tells you in terms of what we're trying to do, right? And so we use different set of sensors. We also use virtual reality. And we wanted to see whether we can actually improve the quality of life by providing different changes to the environment. For example, changes to the door width or the color of the frame or the color of the wall and so on and so forth. So if you can play that video, I think it should be easy from your side.
Yeah, I'm just, I'm not the host right away. I'm just trying.
A few other things which I will copy and paste it. This is for the participants.
It is opening, but it's taking quite some time.
Sure, yeah. I know that it has been optimized for YouTube delivery, but let's see.
Okay.
I did post a couple of information there, so if anybody would like to see, they can go ahead and look at it.
Oh, I'm not able to open this page, Ravi, because it says navigation to this page was cancelled.
Oh, okay. So let me try here. Okay, I think let me give you the narration, hopefully. Okay, so this is a person who has Parkinson's disease, as a matter of fact, and I work closely with the Department of Neurology here. The only problem is, how do I get the audio through this? Let's see. Does anybody know how to get the audio so you can also hear?
Have you plugged in your earphones?
No. Let's see if you can listen. 1 second. Can you hear a little bit?
If you have a caption, right? Also.
Excuse me. So when you are sharing the video, you have to enable the computer audio. You unshare the video, and once you share, there's a on the left-hand side, it's written to enable the computer audio.
Oh, on the left-hand side. Where is it on the left-hand side? Is it part of
there might be one option written when you are sharing your video. Then you have to enable
Yes, got it. Thanks so much. Okay.
Excited about leisure and understanding what it means, how it can bring you joy and take you places you haven't been before. I was diagnosed 2.5, almost 3 years ago. It's really very unpredictable. It's not Parkinson's that kills you, it's the things Parkinson's sets up. I notice in the house that I slip up a little, like I have to catch myself. And every time I have one of these little missteps, I think that could have been the one. Because those falls can mean a broken hip, can mean you may never get back your full mobility. I've seen that.
50 to 60,000 new patients are diagnosed with Parkinson's every year, and it's estimated that there's about 1 million people living with Parkinson's disease in the US. Tremors are a very well-known symptom of Parkinson's, but about 30% of patients with Parkinson's disease don't have tremors. The diagnosis of Parkinson's relies, though, in finding the slowness of movements. That's what really defines Parkinson's, the inability to perform fast, repetitive movements. Typically, we say that when you have seen one patient with Parkinson's disease, you have seen only one patient with Parkinson's disease because of the uniqueness of their specific symptoms.
How do we provide problem-solving home modifications for people like Allie with Parkinson's disease so they can move about and do everyday tasks more easily? This was the question for researchers at the University of Florida. A multidisciplinary team led by Dr. Sherry Erickson developed and tested a virtual reality system to help individuals with Parkinson's symptoms experience moving through home interior simulations with different design features. Participants wore a VR headset and held a controller. They walked on a mat with sensors that were able to calculate their speed, the number of steps it took, whether they were balanced on their feet, and other walking measures. The team examined how walking through different doorways with different widths and frame color may affect participants' movement. For example, people walked through standard doorways or doorways that were extra wide and met ADA standards. Some participants made their own changes in interior features by moving a hand controller to the door width from 26 inches to 48 inches, until they settled on a width they felt worked best for them to walk through. After the VR simulations, individuals filled out questionnaires that ask about their experience and how confident they felt moving through the different scenes. Researchers call this innovative tool COA-TRC, for Co-Design for You, since it allows people themselves what interior features may work best given their unique circumstances. COA-TRC was tested among 15 individuals with Parkinson's and 24 healthy older adults.
This is the first time that someone is using it to see which home modifications would work better for people with mobility impairments. Virtual reality gives us a good opportunity to do a study like ours because it gives us the ability to provide a kind of simulated environment that is very close to real environment, and people can envision themselves, can imagine that they are really in their bedrooms and they're walking towards the bathroom.
The research team has found that COA-TRC was effective in detecting improved movement performance when participants with Parkinson's walk through a wider doorway compared to typical interior doors. They also found that those who had a chance to set up door features themselves had improved movement.
So we envision that therapists, neurologists, those with home modification services, they can use COA-TRC with their patients and clients and help patients to experience multiple variations of home modifications and choose the one that works better for them. We will help them to have a longer independent life because they were engaged in these design decisions for their own homes.
I think this study could be beneficial to people by demonstrating ways that they could lessen their risk of falls, improve their functionality. I'm very happy where I am.
So one thing I want to tell the researchers here is that the research actually happens at the nexus of multiple different disciplines. So it's not just architecture, it's not just something computer science, it actually happens at the intersection of these disciplines. So I'm always a firm believer. If you look at the collaboration here, we collaborated with neurologists, doctors, we worked with engineers, we worked with even the home modification specialists, and I come from the Department of Construction Management, so we do have so many, contacts, right? So we work with so many different, facets of, our home, right? So in order for us to define and refine all of these homes. So that's what I would strongly recommend researchers. Don't just sit in silo. Go ahead, work with your friends. Be collaborative. Have an open mind to listen. Okay, so I think it should be good.
Interesting, very interesting. We'll open the floors now for participants' questions.
So this is the other project. I did kind of send the link. Yeah, they can actually go and look at some of these things. We do design charrettes. Again, this is again part of a formal process, right? Like how we do design charrettes back in India, right? For this. And then we came up with our design charrette briefing book. It's a design charrette book. We will have videos soon here. I mean, you'll be able to see all of these things. This is again part of a larger project, which is $500,000 of project, right? So yeah, these are some of the work. Again, we are finalizing the specific things for the video testing. So we started with, I mean, you saw earlier that we were working with the haptic enabled glove and so on and so forth. But then COVID hit, so we couldn't do all of those things. So we have left with a simple two-dimensional, interface-based, interactions. But we know that COVID cannot stop us. So hopefully in the next few months, we will kickstart the same research. Yeah, as I told you, we have quite a bit of equipment thanks to all of the projects.
Nice. That's something very nice. That's something we look forward to in India.
Yeah,
having a good lab.
Absolutely, yeah, absolutely. And as I told you, right, whenever I write proposals, I make sure that there is a good amount of money for students and for the lab facilities. So this is the Natural Science Foundation project. I think I did post the link. This is again the urban level, right? So the link is in the chat box if anybody would like to see. This is the pilot project. Again, if you look here, we have so many kind of collaboration from computer science to landscape, architecture, art, and some of my own folks here, right? So, and then all of the students. Okay, everybody's here, we work together, and then we have done quite a bit of work in terms of pilot projects. This is the one I was talking about earlier. Okay. All right. So does anybody have any questions? I did see there was one question, but I think the person said that, I think it was Ramsey or somebody. So she said that she had 2 doubts.
Participants, you can switch on your mics if you have any questions. Professor Ravi, can you suggest if there are any open source softwares for simulations?
Yep. For the energy simulation, I use this. I teach energy modeling in my class. I use eQuest. Okay, so there is going to be a smart village project that I'm actually working with university in, I forgot, it's in Gujarat. So I'm going to conduct a short, quick energy modeling course. If any of the members who are attending here would like to join, let me know. Okay. So this is the one. I plan to kind of conduct this course. It's for some of the students who are interested. So basically what we're doing is we're taking a village. This is part of North India. They kind of approach me, and then we run some energy models, and then we are going to implement some cool paints on that particular village. Okay, so potentially in the larger, maybe like a couple of years, they are aiming for a World Bank funds. Hopefully, if that goes through, then they'll be able to kind of develop the village as a smart village. So this is the software I would recommend. This is what I also teach in my class. The software is right here. They can download, they can use this particular software. So this is a free software. The other one is an expensive software, Design Builder. I think some of you may know this, Design Builder. I do have a license, but I don't teach Design Builder in my class because the license is expensive, $2,000. It's not a good idea to do that. So, but I use Energy Plus for my research. Yeah.
Which is why I was asking for open source, because back here in India, even if we want to just try out, we need to have some.
I mean, I don't know. This is the bigger problem what we also face because licenses are expensive, quite expensive, right? Let's say if you want to have a Microsoft Visual Studio license to program, it's quite expensive too. So we do have licenses, but for research purposes, we try to use some of those things. But for the teaching purposes, I don't use any of those licensed software. So those are the things. And okay. So last one, which I want to recommend the participants is they can go to my homepage. You can go to research grants, and then we have ResearchGate. If they go to ResearchGate, they should be able to download most of the papers. Okay, all they have to do is just kind of sign up for the ResearchGate, and most of the papers are already here. Okay, if you go to research, they can download.
Yeah, I was showing them ResearchGate yesterday.
Yeah, they can download articles. And the other one is, as researchers, I think it's important to have a Google Scholar because it's important to understand how your paper is being kind of cited, right? So that's something which they have to know. So Google Scholar is again a very important thing. This was one of the work which we did 2017 with a very high number of citations. This is again, as I told you, we do more on AI also. So that's one of the things. Yeah. So they can go ahead and look at some of these things when they get a chance. So those are the ones. And last but not the least, I also want to recommend them to kind of if they're interested, this is our Rinker School of Construction Management, right? So we do quite a bit of research, and so they should be able to see all of the work that's actually happening. Okay, so this is our college, and then this is our college, by the way. This is our college. So this college has architecture, it has landscape architecture, interior design, construction management, and so on and so forth. So pretty much everybody is right here in this college. And everything is right here. I'm doing some peer work for my department as well, actually.
Yeah, I got it.
All right.
It was very interesting to see the way you have been able to influence the codes that are going to come out in the future, both in Canada and in South Africa. Because here I have seen a couple of people who have done research on urban heat islands. I've seen studies in Madurai, in Chennai, but it's unfortunate that it has not moved on to the next level. It's just stayed as studies. So yeah, I keep wondering how to take it further on. So that was very aspiring to see in your work, the way it's moved on to the next level of getting implemented in practical scenario in the urban scenario.
That is true. That is true. I think in the case of South Africa, we were fortunate enough because it was funded by the US government, Department of Energy International. And South Africa is a developing country, right? They also need somebody from the outside to come and run some studies. So when the US government was involved, they did mention about having a technical action committee as part of South Africa. So the South African Technical Action Committee or group TAG, that's what they say, Technical Action Group. The group consists of the architects, engineers who are specifically focused on building energy. So we convinced them, okay, and they convinced their own government, Okay. So I still remember we had several meetings, and one of the last meeting was actually held in the South African National Standards offices, where we had the entire TAG committee. It was close to 20 people. They all flew into that particular meeting. It was in Pretoria. And, they were very much convinced. And, the important thing is, the problem is most of the research kind of, gets stuck as a research paper. And that is not what we want. We wanted to make sure that, it's being kind of, it goes to the actual implementation, and then people actually use it, right? So that's something which we have to really be cognizant of. It's good to see citations. It's good to see that, you have a good number of followers in ResearchGate, but it doesn't mean anything unless people actually use it.
I know, true.
Yeah, and sometimes, you should do for the love of it, right? One of the first things we did for South Africa was just for free, right? We just said, why didn't we do this? Okay. The smart village, the one which we're working is actually for the same thing, same purpose. We're doing the same thing for the smart village. So hopefully, yeah, I don't have the particulars here, but I will share this with you.
So I think that's probably one step of, converting PhDs to reality. You start pro bono and then move it across. Nice.
Yeah, well, PhD research by itself is pro bono, right? We spend like 5-6 years.
I guess so.
Advisor,
true.
Right? Yeah, but the good thing is, it's like a tree. That's why I put a tree diagram. So basically now my students, the way how they write publications is the way how I would write publications, right? So you kind of teach them, and then they go, and then they are in the environment, they are in the academia, or they are in the industry. But as I told you, all 4 of my PhD students are already in the academia, in the industry. So basically they're making changes to the industry.
Yeah, that's very satisfying.
Yeah. To me, it's not, because I wish they were in the academia so they can go on change minds and bring students and put them in a cage. They don't do that.
Okay.
All right.
Okay. So do you have any questions from the participants? I guess
I don't have any. I have only one question. I don't know why they're extremely shy. No idea. I get up in the morning. I'm still kind of okay with a 1 cup of tea, but they had, I don't know, vada sambar or whatever, and still they are kind of very shy.
Yeah, it's post-lunch session for us, Ravi. So.
Oh, really? Okay.
Yeah, it's 5 now. It's going to be 5. So.
Ready for dinner time. Yeah.
Okay, guys.
Again, sorry, go ahead, Lakshmi.
No, I'm sorry. I was just asking if anybody. I guess there are not many people who are interested in this area, is it?
Excuse me, ma'am.
Yeah, please.
This is Supri this side. Sir, I just wanted to ask one question which is not related to this area, but in general, I just wanted to know that due to COVID, like nowadays, students find it very challenging to, gather information, or maybe do the surveys, currently what situation there is in India. So I just wanted to know how your students do the primary survey. Are there as in any kind of as in some sites or some sort of as in fabricated system or something like that at university level or something that helps them for the primary surveys, to conduct primary surveys? I just wanted to know that.
Yeah, that's a very good question, Supri. So as a matter of fact, we suffered a lot because, as I told you, right, we have to make changes to our research program, especially with the ongoing HUD project, purely because, COVID, just very similar to India and the US, there are extremely lots and lots of regulations. In the US, we had the CDC that said, hey, you cannot have 2 people in 300 square feet area. So pretty much I can go to my lab, I can hardly have like 3 people sitting in one big room and myself another room, right? So huge restrictions. I do agree with that. We tried to, let me tell you this, the first 3 months was really terrible because we couldn't do anything, literally. We were making sure students are safe. I said, don't come to the lab. I don't want to see you guys. And then we started to work on Zoom. weekly meetings and so on and so forth. But slowly, as people kind of got used to COVID for some reason, they slowly, they said, okay, you know what, we are more than happy to kind of conduct interviews or over the Zoom, right? So it took some time. Yeah. One thing, Supri, which I want to let you know is it's affected pretty much everyone, not just you or me or Lakshmi's research. So I think it's kind of the whole world literally stopped, and then slowly we're recovering. So I think it's kind of understandable. But let me also tell you this: this is a good opportunity for all of you to kind of spend time and develop and write and submit your journal papers or conference papers. Okay. I do agree that we have slowed down in terms of conducting research, but that should not stop you to disseminate research. So that's what I tell my students. And just during COVID, usually I publish like, 6 journals or 5 journals a year, but during COVID, I published 9 journals. Okay. I motivate my students and then I tell them, what, let's go ahead and let's publish. I mean, what are they going to do? I mean, how much of Netflix can you watch, right? Okay, so, why don't they go ahead and publish? So you need to motivate. Yeah.
Thank you.
Yeah. We could, as I told you, even for the HUD project, we were supposed to use a mat. We were supposed to use all sorts of sensors, but then COVID restrictions, we cannot have, in the US, if somebody is wearing a goggle, somebody has to hold them. Okay, so that's not social distancing anymore, right? So couldn't even do that. So we have to completely close that research, and then we came up with another alternative. And we're going to finish the research in September, but I'm going to request for some additional money so we can finish up after COVID.
When Ms. Supri put that question, I was going to tell her he's more of a drone and an AI man. So come on, not a problem getting data.
Right.
By the way, I should also tell you guys, machine learning, most of us, I believe, in this community are Indians, right? Indians are pretty good at math. Okay. I got into machine learning in 2005 when I was a PhD student, and now, it's kind of exploded like anything, right? And we do a lot of work on that as well. And some of the fundings, I'm actually going to work with Daikin Systems. Daikin is actually basically a Korean company, I believe. They have an office in the US. We're actually finalizing some of these things. They have so much of data. The question is, how do you understand the data? So we are looking at all of these things. So we're almost finalizing a contract with them, and we'll be looking at data and trying to help them understand data. Okay? Just so data is king. So I think we should all get into AI, machine learning. The Chinese government is spending quite a bit of money on AI, and the US government has started to put in a lot of money on AI. I think as young researchers, I think if you don't focus on using AI to understand data, I think we're losing something.
Sure. Right.
Again, if you're interested to pursue master's or PhD, you know where to go now. I see all the applications that comes to my department because I'm the official authority there right now. So.
Right. So if there are no more questions,
let me ask. I don't know who the fire. Okay.
Would you like to say something, Professor Ravi?
No, I just want to tell them that they wanted. I wanted everybody to kind of open up their eyes and see, look around and see if there is a problem that you can actually solve with simple solutions. Okay, not necessarily using drone and everything, but try to see if you can actually develop some solutions that would actually go all the way to solve solutions. And I was born in a village in India, right? So slowly getting there and all sorts of things. I think we should just keep your eyes open. There are always some things which you can solve and collaborate with people. That's huge. A lot of notes. Thank you everyone for your kind notes, and just keep things going, and let's do wonderful things.